Imagine for a second a high-tech vending machine. But instead of just spitting out snacks, it handles agreements for, well, pretty much anything. A loan, a property sale, a shipment of goods, all done instantly, automatically, and with no middleman. That, in a nutshell, is the wild idea we're diving into today. A world where legal contracts are literally written in computer code.
All right, so here's our game plan. We're going to start with the big promise of these automated agreements, and then we'll get into the messy collision that happens when that code slams into centuries of law. We'll even see this play out in a real-world clash of blockchain titans. From there, we'll explore how this same tech could totally reinvent our digital identity. And finally, we'll tackle the biggest question of all. With a technology this powerful, who actually gets to make the rule? So first up, let's unpack the core idea that's driving this entire revolution. What if we could design agreements that were just better? Free from human error, frustrating delays, and all the hidden biases that come with them. That's the dream of automation.
I mean, this is really the fundamental question, isn't it? For centuries, we've had to pay lawyers, banks, and courts to be the referees for our agreements. But what if the agreement itself could be the referee? What if it could just execute its own terms and completely cut out all those middlemen? Okay, so here's the basic concept, put pretty simply by IBM. A smart contract runs on a super simple logic. If this happens, then do that. And all of that is written directly into code and stored on a secure, shared ledger, a blockchain. It's an agreement that's both defined and guaranteed by the tech itself. And here, you can see that whole life cycle in action. It all starts with a familiar legal agreement, right? But then it needs a way to know what's happening in the real world. That's where this thing called an oracle comes in. Think of it as a secure data feed that tells the contract if a condition has been met, like, say, a package has been delivered. As soon as the oracle confirms that delivery, bam, the contract instantly executes the outcome, releasing the payment. It's all automatic. No invoices, no follow-up calls. And this kind of automation brings some really huge advantages. It's way faster, since everything executes immediately. It builds trust, because everyone is looking at the exact same unchangeable record. It's incredibly secure, thanks to how blockchains are designed. And of course, it saves a ton of money by getting rid of all those costly intermediaries. But this promise of perfect automation leads to a really fascinating conflict. What happens when the rigid, absolute black and white world of code smashes right into the flexible, nuanced world of law? Well, as you can probably guess, sparks start to fly. This quote from Federal Lawyer magazine just nails the tension perfectly. See, traditional law is designed for human interaction. It gets ambiguity, it gets intent, it gets that people change their minds. Technology, on the other hand, does not. This is forcing us to completely rethink what an agreement even is. So think about it. A traditional contract might use a phrase like best efforts, and a judge can figure out what that means. A smart contract, it needs precise, objective triggers. You can agree to change your paper contract, but a smart contract, once it's on the blockchain, is immutable. You can't alter it. And while you can choose to breach a traditional contract and deal with the consequences, a smart contract just executes. There's no such thing as a breach. There's only the outcome that was written in the code. Okay, so let's make this abstract fight a little more concrete. We're going to look at a real-world battle between two of the biggest platforms where these smart contracts actually live, Ethereum and Solana. And this isn't just about two competing pieces of tech. It's a genuine conflict of philosophies. It all boils down to this concept called the blockchain trilemma, the idea that you can't perfectly maximize security, speed, and decentralization all at the same time. You have to make trade-offs. And, well, Ethereum and Solana have made very, very different ones. First, just look at Ethereum. It has over $85 billion locked into its applications. That makes it the undisputed king of decentralized finance. That number isn't just money. It represents an immense amount of trust in its security. It's basically the digital Wall Street. And then you've got Solana, which is all about one thing: speed. While Ethereum might handle, say, 15 transactions a second, Solana is built for a theoretical 65,000. That's the kind of insane performance you need for things like high-frequency trading or massive online games. And here's the secret to Ethereum's security. It has over 1 million validators. These are independent computers all over the world that confirm transactions. This huge decentralized network makes it incredibly tough to attack. Solana, on the other hand, has fewer validators because it requires much more powerful, specialized hardware, and that's a direct trade-off it makes for all that speed. This table really breaks down their core differences, and a key one is architecture.
Ethereum is what you'd call modular, meaning it separates different jobs to prioritize security above all else. Solana is monolithic. It bundles everything together for maximum speed. It really is a choice between a secure fortress and a high-speed racetrack, and developers have to decide which one matters more for what they're trying to build.
So these platforms are the foundation. Now let's look at one of the most powerful things you can build on top of them. A completely new way of handling something we all use every single day, our digital identity.
You know, the idea here is pretty revolutionary. Right now, your digital identity is scattered across dozens of corporate and government servers. But with self-sovereign identity, or SSI, you hold the keys. This completely flips the power dynamic. You are in control of your own data, and you decide exactly who gets to see it and when. So here's how it works. A credential issuer, like a university, gives you a verifiable digital diploma. You store it in your own digital wallet. Now, when a verifier, like a potential employer, asks for proof of your degree, you present only that one credential. They can then instantly check that it's authentic on the blockchain without ever seeing any of your other personal data. It's perfect privacy and perfect verification all balanced together.
So we have this world-changing technology for contracts and for identity. But how in the world do we govern it when it operates instantly, automatically, and across every single border on the planet?
This timeline really shows regulators playing a long game of catch-up. I mean, from the time the original Bitcoin white paper came out in 2008, it took years for legal bodies to even start responding. We've seen this slow evolution from some initial guidance to much more comprehensive frameworks, like the EU's directives or Singapore's pretty forward-thinking Payment Services Act.
And what this really shows is that no single group can manage this alone. The future really depends on a super complex collaboration. You've got national regulators, financial institutions, the tech companies themselves, and international bodies all trying to figure out how to work together. It's a global technology, so it absolutely demands a global solution.
And this leaves us with the final and maybe the most important question of all. Technology is accelerating at an exponential rate. Our legal and regulatory systems, though, which were built over centuries for a physical world, they tend to move at a much slower, linear pace. Can we close that gap? Can we design legal frameworks that are as agile, as borderless, and as innovative as the technology they're supposed to govern? That is the challenge that's going to define the next decade.